Okay, section 5.5, we're talking about systems of inequalities. We have seen that equations in the form of ax plus by equals c are straight lines when graphed. If we change the symbol, the equal symbol, to greater than, less than, greater than, equal to, or less than equal to, we now obtain a linear inequality in two variables. Some examples of linear inequality in two variables are x plus y greater than 7, 3x minus 5y is less than or equal to 15, 2x minus y is less than 8, and so on. A solution of an inequality in two variables, x and y, is an ordered pair of real numbers that when substituted for x and y in inequality yield a true statement. Okay, so here is a line. Okay, so this is whatever the equation line would be equal to this. And this line is actually the line x plus y equals 2. Okay. On this side, it's going to be x plus y is less than 2. And this side is going to be x plus y is greater than 2. Those are half planes. So everything on this side is going to be the x plus y is less than 2. And then everything on this side is going to be x plus y is greater than 2. And of course the line is going to be x plus y equals 2. Okay, how do we solve a linear equation or inequality in two variables? First, we're going to replace the inequality sign with an equal sign and graph the corresponding linear equations. We're going to draw a solid line if the inequality contains a greater than or equal or less than equal symbol, basically an equal sign in it. We're going to draw a dashed line if the original inequality contains one that does not have an equal sign on it, an inequality sign without an equal sign. Then we're going to choose the test point from one of the half planes. Do not choose the point on the line and substitute it into the test point into the inequality. If it's a true statement, we're going to shade in the half plane that contains this test point. If it's a false statement, we're going to shade the other half plane not containing this test point. Let's do an example. Here I want to graph linear inequality into that variable. I'm going to graph this right here. First, we're going to look at 2x minus 3y equals 6. We look at the actual line. And we know that we have this inequality sign with an equal sign here, so it's going to be a solid line. I'll make a little note here so I don't forget that. If there had not been an equal sign here, we would make a dashed line. So now we're going to go ahead and graph this. So we can graph this however we want. Go back to chapter 2. We did y equals mx plus b, or did the intercept method. So I'm going to use this one. I'm going to use the intercept method. Or if you want to, you could do y equals mx plus b. This is a great review for your final exam. You should not do this. I put in, to find the x-intercept, I put in 0 for y, so I get 2x minus 3 times 0 equals 6. So I get 2x equals 6, and x equals 3. So I get 3, 0. And for the y-intercept, I put in 0 for x. So I get negative 3y equals 6. So y equals negative 2. If I divide both sides by negative 3 to get that. Okay. So that order pair is going to be 0, negative 2. So we'll go ahead and graph those 2 points. So here's 0, negative 2, and 3, 0. And you should have, use a ruler. I don't have one like using my iPad, but you're going to go ahead and graph the line. And make it a solid line, I told you a second ago it would be solid. Okay. And so now what we have to do is we got to find a test point on this side or this side. You can pick any point. I could test the point 0, 0 on this side. I could test the point 6, negative 2. It doesn't matter. Okay, so I'm going to test 0, 0. I always like test 0, 0 if it's in one of the planes. I'm going to test 0, 0. So I'm testing something on this side of the line. So if I put inequality, so I do 2x minus 3y is greater than or equals 6. I'm going to put 0 in there for x and y. The question is that a true statement? So I'm going to put a question mark here. So I get 0 is greater than or equal to 6, and that's false, right? So that means wherever this point is, I don't want to shade this region. I want to shade this down here. So I'm going to go ahead and pull my paintbrush out here. You have your pencil, or if you have a marker, whatever you want to do there. I'm going to shade in this region right here. Again, the lag in my iPad, so if I can get down here. There we go. I'm shading in this region right here. So any point that you pick down here would work. So let's say if I really want to test another one, you don't have to. Let's say I want to test a point 1, 2, 3, 4, 5, 6, -2 will be right there, right? The 6, -2. It should work. So 2 times 6 minus 3 times -2, is that greater than or equal to 6? And I get 12 plus 6, which is 18. 18 greater than or equal to 6, that's true. So any point that you pick in this region will work. Okay. So on your own, go ahead and graph this line of inequality by graphing the line, then test a point in one of the regions and shade in the appropriate region. I'll go ahead and pause the video and you can try that on your own. Okay, so I graphed this linear inequality and I made sure I'm going to do a solid line here, got that equal sign here. I graphed the line, I got the 2 points that would make up a line. And I tested 0, 0 because on this region here, and it did not work, it was false. So I made sure I shaded the other region, and that would be the solution to that inequality. Okay, for example 2, I want to graph the linear equality in 2 variables. Again, I'm going to do the same thing here. I'm going to go ahead and graph this y equals -2x, or -2/3 x. Before I go ahead and make my line, this is going to be a dashed line, because I know that I don't have the equal sign here, so I want to make sure I don't include that line as part of my inequality. So now I'm going to graph this, and this is actually from y equals mx plus b. Remember that? So m is -2/3. I'm going to go down 2 units to the right, 3. And my b is 0, so my point is 0, 0. I'm going to start at 0, 0. And I'm going to go down 2 to the right, 3. Down 2 to the right, 3. So I'm going to go ahead and draw that line, and make sure it's a dashed line. We don't want to include that line as part of my inequality. Okay. Now I test a point in the region. Again, I can't test 0, 0 because 0, 0 is on that dashed line. I want to test a point up here or down here. It doesn't matter which one you test. I'll test something up here. So let's test 2, 2. Okay, so is 2 greater than -2/3? Actually, I would probably want to test something not 2, 2. Let's test something else. Since this is a fraction, I'll test where x is 3. So I'm going to do 3, 2. Okay. So I get 2 greater than -2/3 times 3. I get 2 that greater than -2, and the answer is no. Or false. True, my bad. Yes, true. So I touched a point up here, which was 3, 2, and it works. I'll make sure I'm going to shade in that region up there. Okay. So on your own, go ahead and graph this inequality and then do the thing that I just did in that last example. Go ahead and pause your video. Okay, so the on your own problem here, I get this region up here after I graphed the line, and I tested a point up here and it was true. If you tested a point down here, that's completely fine. If you tested a point down here, you would have found that the statement was false, and then you would have shaded up there. Okay, so let's go to the next example. And whenever you're graphing inequalities and there's not both variables in there, just an x or just a y, I tell students that you don't want to do a test point here. You can if you want to. So in example 3, I want you to graph y is less than or equal to -3. If I try to graph y equals -3, that would be a line down here. That line right here. Again, we're going to look at this is going to be a solid line. Oops. Change myself back to a pen there. It's going to be a solid line. So I'm going to go ahead and graph y equals -3. That would be right here. Oops. And then if you want the y to be less than the -3, you're going to shade beneath it. So I would shade this down here. If you don't want to, you can touch a point, but that's a little bit more easier to do than touching a point there. And then if I want to graph x is greater than 2, I know it's going to be a dashed line. Okay, so where x is greater than 2, what x equal to would be this line right here, but I'll make it dashed. It would be greater than 2, all the x values that are greater than 2, that would be on this side right here. So I'm going to go ahead and shade in this side right here. We only have one variable, it's a little easier, I'm going to use the test point there. Okay, so on your own, go ahead and do the next two on your own, and then we'll move on. Pause the video, please. Okay, so here are the two answers. I have a dashed line for the first one, and then a solid line for the second one, and I shaded the appropriate region to make the inequality true. Okay, so what happens when I try to graph a system of linear inequalities? So now I have more than one inequality. And so this example right here, what we're going to do is we're going to look at each one individually, and I have graph it down here. So here I'm going to graph x minus y is less than 1. So I'm going to go ahead and graph that. I'm going to go ahead and look at do the intercept method. So I get 0 minus y. Let's do the x-intercept first. So I get intercept method. So I get x minus 0 equal 1. And I'm looking at x minus y equal 1. So I get x equals 1, so it's 1, 0. And then I have 0 minus y equals 1, so negative y equals 1 divided by negative 1. I get y equals negative 1, so 0, negative 1. I'm going to go to my graph paper here. And I'm going to graph 1, 0, and 0, negative 1, which is right there. It's going to be a dashed line. I'm going to be running out of time here for a 15-minute break here, a 15-minute time limit. And then with test point, I'll test 0, 0. So 0 minus 0, that less than 1, is 0 less than 1? Yes. So I'm going to go ahead and shade in the region that has the 0, 0, which should be this region up here. Okay. I think I'm getting ready to run out of time. I don't think I have time to graph the other one, so I'm going to stop right here. So we'll pick back up on this one in the next video. Pick back up on this example. Actually, I might have time. Let's go do it quick. If I get cut off, I'll get cut off. We'll do a different. We'll finish up next video. So here I have 2x plus 3y. I'm trying to hurry up and I'm messing up. 2x plus 3y greater than or equal to 12. It's going to be a solid line. And so I'm going to go ahead and do 2x plus 3y equals 12. So 2x plus 3 times 0 equals 12. 2x equals 12. So x equals 6, so 6, 0. And then 2 times 0 plus 3y equals 12. 3y equals 12. So y equals 4. It's going to be a solid line. I'm doing this in red, so 0, 4 is right here. 6, 0, 1, 2, 3, 4, 5, 6 zeros there. And a solid line. Now I'm running out of time, so I'm going to go ahead and draw my solid line. Okay, I'll pick it up in the next video. So I'll start right here.